It's time to hit some log properties. I know you're itching for new information. You're like, man, I want to do more. All right, so log properties. If I have log base b of m times n, I can expand this, okay? So this would equal log base b of m plus log base b of n. So you know when we say like logs are exponents or the answer to a log is an exponent, their properties follow the same. If I am multiplying like bases, like say x to the fourth times x to the third, I would add my exponents and get x to the seventh. So the multiplying and the addition goes together like we have with exponents. They follow the same properties, okay? So if we use that same logic with division now, well, I'm going to have log base b of m, and if you remember for division of like bases, subtraction is what happens with our exponents. So minus log base b of n. Now, these work both ways. If I have them in the expanded form, I can go back to the condensed form and vice versa, okay? Now here, I have like that power to a power rule. So what we have is then r times log base b of m. I can move that exponent out in front of the log. Okay, now a couple special cases. When I have log base b of b, that's basically taking the log, the base, and the argument are the same, it would just end up equaling r. Okay, so if you want to show that, I could say, well, I could move the r out front, r times log base b of b. I know that the log of itself, right, the log base of itself, that's just going to equal 1, so r times 1 is just r. Okay, that'd be a little short proof of it, I guess. Okay, and the last one here, b raised to the log base b of r, follows the same idea here, and I'm not going to go through the explanation of it. It gets kind of weird with the algebra, but know that it's going to equal r, okay? So there we go. We have some awesome log properties. They are fantastic. They are wonderful. There we go. We've got everything. I can just move myself out of the way. There we are. I'm gone. I'm gone forever. All right. Hope you guys enjoyed it. See ya.